Hello, hello, hello. I am here to do Everybody Codes Quest 11. Again, 11, the anytime you want nature of these ones. I'm taking full advantage of it. So, got my code up, not wallbang, my work machine. I am ready to go. Let's do this. Okay, we have some things. We're going to split. Looks like a graph. 5 termites. Okay. So, well, fourth, eight. Wait, which one? Fourth day. 8 termites. Okay. A converts to B and C. I see. Wait, what am I looking for? Calculate total population based on conversion notes. A converts to B to C. B converts to C to A. C converts to A. Okay, so it's counting and multiplying. Gotcha. Changes notes split on the new one. Let me turn Copilot off real quick. There we go. Map out. Const from raw 2 equals split on that column. Turn, well, let's make it happen a bit. Const G from, if these only occur once, so I can do it like this, equals raw 2 split the comma, and I can already see optimizations needing to be done for all of this. So populations, and this is going to be a map of counts. Let d equals 0, d less than or equal to 5, d plus plus, and it was 4. 4, there we go. New pop equals this, so 4 cost from count of populations. I guess I'm just doing the keys, I guess. From, then it'll be new pop, there'll be 2. Will be for each 2 for const 2 of G from, come on, get in there, new pop 2 equals new array. Let's do the check if not new pop 2, let's do new pop 2 equals 0, there we go, new pop 2 plus equal count, right? So we have populations, we have counts, populations from. There we go. That should do it. For const n, there we go. Fix that. That'll be populations equals new pop, not new promise. New pop. There it is. Make sure this is still working. Yep, still working. So we have our new populations here. We'll just do this. It's the counts. So it's the counts on those days. Return object.values, populations reduce, A plus, B start at 0 because nobody cares. Let's see if this works. Okay, I'm getting 0 instead of 8. I have to initialize the populations. A, start with 1A, right? There we go. 13. Did we go too far? I think we went too far. Boom. Give me real notes. Let's watch this work. Okay, 39. Let's see what happens. Beautiful. The new termites start. With general rules. Okay, rules stay the same. We have a Z termite. Don't know what that means. Don't get an example. Starting from a Z termite instead of an A termite. Do I have Z's in here? In the new example, yes, not in the old, which means I don't have an example 2. Solve quest 2. Let's just pass it starting. And then we'll say start equals A. We can say start equals 1, right? So part 2, just do that. That's a number. It could be right, it could be wrong. It's wrong. Okay, they're really changing this UI. Love it. Okay, the new termite starting from a single category Z termite. Oh, in a different way than previous. 10th day. And then day. 10. Jeez. That's what you should read. Day equals 4. Sure. I think I have a minute, so let's run it. Yep. Number be big. Let's give me the correct number for this. While I'm here, it's 39. Shove that in there. Count 4. I have a number. I have 7 seconds. Part 1 still works. Part 2. Sure hope this is it. 27 something something 38. Nice. Okay. Oh, I start with different things, and then I do 20 days. Which initial will yield the largest and smallest? So I do it A to Z and then 20 between these two populations. Okay, great. I can do that. I do have an example, thankfully. Nope. Give me that. Paste in there. This. Solve quest 3. Solve quest 3. My input. I like this one. I can knock this one out. I don't even think I'm doing too many computations, honestly. Solve quest 3. 2. 3. Day is 20, right? So I don't even think I need to do. So parsing's going to be unoptimal, but let's just do this. For let car equals A. Let's just do for conch car of alphabet and populations is the start. We get our value here. Total is here. Let least equals math dot max. Nope, number dot max. Let most equals number dot min. Make cost alphabet. Just go steal that from somewhere. Just give me the alphabet. Just give the alphabet. I just want it in order. I don't want to take this out. This is really complicated. Just grab all the spaces. I kill everything after a space. Kill a space, everything after the space. Boom, we have it. Solve quest 3. With car, get your total. Least math dot min total least and then total. Then we have most total return. What is it? Largest minus smallest. Most minus least. It's really pushing my algorithm. If I have any problems, I will not be able to easily identify it. You don't need this notes of splitting, try populations like that. I think this is it. I do have example tests on. G from is not curable. Or empty array. Didn't realize this would ever happen. It's slightly concerning. Can I roll Roy? -9. Oh, we didn't find. Okay. For car of alphabet. Day count. Day count is 20. So quest 3. 20, right? 20. Let's put that in there. Do it for our friend before we forget. Got it. Let's hit it again. Ooh, thanks. Still not hitting it. That is an alphabet. I'm using day count. It's 20. let's step through it, I suppose. Let me open up my tools. Step through. Okay, for character of alphabet, we're doing it. We're getting a total. I just did min on both. That's a problem. Stop that. Let's run it for real. 44. Hope I see it. 44092. Subtracting the smallest number from the target. Wait a minute. How the initial termite type. Oh, so I should only look through all the initial termite types, not the entire alphabet. Got you, got you, got you. Const T types equals new set. Just do that. T types, and then will be T types add from T types add for const each of thing. T types add each. And the thing will be G from, because you just went through it. And it will be for each T types. I just did it to the wrong one, so let's copy that. Doesn't hurt that one, thankfully, but we're going to control Z, time travel that one. Okay, we have that working. I can ignore that message, thankfully. Okay, let's get back to VS Code. For car, I have T types. Don't worry, it's a thing of strings. Don't you worry. Let's see if that likes it. Boom, which means it might be it for 3. It's a big number. And we got it. Okay, I'm surprising the difficulty curve kind of dropped for day 11 here, but I will not be complaining. Everything works. Put my actual answer in for that one. Boom, day 11 out of the park. Let me clean this up and okay, let's walk through the actual problem. So we're given a number of before and afters. So before, if you have a termite A, it'll turn into 1B and 1C. If you have a B, it'll turn into a C and 1A. If you have a C, it'll turn to an A. So first it's parsing this. I again chose a directed graph. So you are here, can go to here or here. And yeah, you're supposed to emulate this for X number of days, where X is 4 for the initial. So your 1A turns into 1B and 1C. 1B turns into a C and an A, and then an A turns into a B. So lots of just more and more and more and more things in this map. Part 2 is just starting from Z, which I imagine is just more computationally, more memory impact here if you did it the bad way. Then part 3 is wrapping this by trying every possible initial termite, because before you start off with A, part 2 start off with Z. This one you try every possible termite. That shows up in the graph. You don't try termite G if there's never a G in here. And then you effectively subtract the one that generates the most termites from the least to get the answer, the population difference. It also bumps up 20 days, which, again, inefficient algorithm would have been busted on. My solution for this was relatively straightforward. So straightforward that I was able to reuse most of it for 1, 2, and even 3. First, I create a graph, and then I unnecessarily map through it. So for every line, I split on the colon. Then from that, I get what's on the left of the colon, what's on the right of the colon. So I get the letter A, then I get B comma C. I turn B comma C into an array of B and C split. Then I add this to my graph, key being what you turn from. And then I already started off the optimized version. I could have just had an array of current bugs and old bugs and just been pushing and pushing and pushing. I decided to go straight for counts. So instead of having 10 A's, I just have A, and I'd say there are 10 of them. But of course, you start off with a 1, so you say whatever the starting character, A, you have a 1 termite, and you do this for every day iteration. So the actual day is useless. We generate a mapping of the new populations when we go for every current termite to every termite it can turn into. And we say, hey, if we haven't seen you yet, then we're going to set you to 0. Otherwise, we have seen you. We're just going to add however many there currently are. So if there are 10 A's and we're about to make some B's, then we just say the number of B's is plus equal 10. So we just add 10 to the number of B's. And then once we're done with this, we have a new populations map. We get rid of the old one, replace it with a new one. The last bit is going through all of these counts. We just want the counts, so we do object.values, and we sum all the numbers in that array. This works for quest 1 and 2, because you only change the day count, you only change the starting bug or termite. For day 3, or quest 3 rather, it was the same, but I wanted to keep track of all the possible termites, so I made a set that was all the values and all the keys. In hindsight, I probably could have just used the keys from the object, but there's a possibility where we say we turn into, for example, termite C, for example. We make termite C, and then there's no termite C just lives in the universe. It doesn't turn into anything else. I'm not handling that. So I was just like, just give me all the possible termites. The set will remove our duplicates. And I set up our values we're collecting, the highest and the lowest, set them to min and max appropriately, so our math.min and math.max will work on them. And I go through every starter termite of the possible termites. This code is nearly identical. They have to optional chain, I believe, to an empty array because there are some termites that, like I just described, do not have a from. So like if you turn into a C, and this line wasn't here, you would die. So there's nothing for them to turn into. Then what we did is, well, we generated the total, and we were like, okay, if you're the smallest, you're the smallest. If you're large, you're the largest. Subtract largest from smallest. And that was it. That was our initial problem. Well, that's the challenge, rather. That's the solution. And we'll commit that away. I'll commit that away later. So that was it. As always, it is a pleasure. Okay, so now it is a refactoring time. Not going to walk through the solution or the challenge because I just did that, but let's see where we can optimize this. So thankfully, most of this is the same code. We have the parsing of this, and then we have the calculating of the population as after n number of days. That can mostly be done. So const parse, what do we call these? Conversions, notes string, and then that's a great name for our graph too, which is more accurate. It is conversions. Conversions, return conversions, and let's just go ahead and do this as a reduce, because that's what we're doing anyway. Conversions, and then we have a line. We have these bits. Let me put that message. Awesome. So line conversions from, return conversions, empty object as record, string, string array, just like that. Yeah, I think this is literally perfect. We have our conversions, and then it will be, what do we want to do this? I think we want to do this including the outer loop. So population total at n days. So function calculate population after days. And then what we'll do is we'll have conversions, record, string, string array. Then we'll have days number. And we'll have initial termite string, because that's our character. And it's going to be basically this. I'm using this one because this one has the fail if it doesn't exist. Initial termite, days, and we don't actually need D for anything, so you're an underscore. G is conversions, and we return that math right there. I love it. Let's use this for 1. So I'm doing it out of order, but let's cost conversions, parse conversions, takes in the notes. This one takes in conversions, the days, and then the initial termite. I'm changing all of these in my parameter right here. Initial termite, days, we can drop all of this. And when, well, they should all still work. I haven't broken 3 yet. Like a charm. And we're going to do the same thing to 3. I'm going to see if I can use the keys of this instead. Let's try. I don't have conversions yet, but we'll make it. Notes, there we go, drop that. Do the exact same thing, total equals calculate populations after n days, conversions, day count, and the initial termite is char. Now let's see if we did or did not need that set. We did not need it. Love it, the keys are sufficient. Let's just make a cool name for this. Population. I love it. We can drop start. We can rename day count to days. Right, so now it's just polishing these up and giving these better names. So solve quest. Let's remove all of our defaults. Make the other functions work for it. Yeah, you start with an A, you get 4 days. Start with an A, you get 4 days. Boom. We don't care what you start with. Your days are numbered. Your days are 20 and your days are 20. Loving it. I think these names could do a little bit better. So what's this do we really ask for as word problem? I'm fine. Just calling it as is. 1 and 2. That's fine. Okay, so now the new solution. They all start off with the parsing of conversions, which takes the notes, breaks it up line by line, and uses an accumulator, which is then record of string to other strings, goes through that. I'm not going to re-explain it. It's the same. And then they all eventually calculate population total after days, which takes these conversions, the number of days, and the initial term. I'm not going to walk through this again. I've already done it. 3 is the one that really takes advantage of it, where we generate the conversions once, and then for every key in our conversions, so we didn't need to look at the values, the keys were sufficient. We calculate the population, we say least or most, and then finally we subtract the most from the least. We find that difference. And yeah, that is the refactoring. Like I said, day 11, difficulty got a little easier. I'm expecting day 12 to be a real sticky one. But with that, it has been a pleasure as always. Hopefully, something was learned. Bye bye.